Hi guys, let's look at the second and the last part of this chapter, distance formula. Quick revision, we know distance between 2 points can be calculated using this formula x2 minus x1 whole square plus y2 minus y1 whole square. And then we did a question about rectangle where we proved it to be a rectangle by proving that opposite sides are equal and then the diagonals are equal. Similarly, we can do for isosceles triangle, we can do for a right angle triangle by ensuring that by applying Pythagoras theorem. So now let's look at question number 13. Question number 13 is prove that the points A, B and C are the vertices of an isosceles right angle triangle. So we need to prove two things. One, that this is isosceles, and two, that this is a right angle triangle. So isosceles we'll prove using two sides are equal, and right angle triangle we'll prove using Pythagoras theorem. So let's look at it. Let's say this is A, B and C. Let's find the value of AB, the length of AB. Length AB will be equal to 1 plus 3 whole square, that's x1 minus 3, that's 1 plus 3 plus negative 3 minus 0 whole square. So this is 4 square, that's 16 plus 3 square, that's 9. So AB is equal to 12 square root of 25, which means 5 units. So AB is equal to 5 units. Now let's look at BC. So let's look at BC. So BC will be equal to negative 3 minus 4 whole square plus 0 minus 1 whole square, which means this is negative 7 whole square, which is 49, and this is 1. So this is equal to square root 50 units, which is equal to 5 root 2 units. 5 root 2, yes, that's 5 into 5, 25, and 2 remains inside. Perfect. Now, so obviously AB and BC are not equal because they are of different length. Now let's see if AC is equal to it. Let's try. So let's check the length of AC. AC would be equal to 1 minus 4 whole square plus negative 3 minus 1 whole square. So 1 minus 4 whole square would be equal to negative 3 whole square, that's 9, plus negative 4 whole square, that's 16. So this is equal to square root 25, which means equal to 5 units. Now this is AC. Since AB and AC are equal, therefore triangle ABC is isosceles. So we've proven one part of it, that this is isosceles. Now let's look at proving that it's a right angle triangle, which means I should be able to prove it to be isosceles. Right? So this side and this side are equal, and they are given equal to 5 and 5, which means AB and AC are equal. So this is AB and this is AC are equal. Let's see if Pythagoras theorem is applicable using we can't use Pythagoras theorem because we don't know if it is valid. So let's try the converse, which means let's try and prove that BC square is equal to AC square plus AB square. BC square will be equal to 5 root 2 whole square, which is equal to 50 units. And AB square will be equal to 5 square, which is 25, not units, my mistake, this is 50 square units since we are squaring. Right, my mistake, this is unit square, this is 25 square units, and AC square will also be equal to 5 square, which is 25 square units. Now since BC square is equal to AB square plus AC square, using converse of Pythagoras theorem, which means Pythagoras theorem states that if triangle is right angle, then hypotenuse square is equal to the sum of the other two sides square. But converse would be if the hypotenuse square is equal to the sum of the other two side squares, then this is a right angle triangle. So using converse of Pythagoras theorem, triangle ABC is a right angled triangle. Therefore, triangle ABC is an isosceles, because we already proved it isosceles, a right angled triangle. So we've proven both the part. How did we do it? We checked the measure of two sides, if their two sides were equal, and then we applied Pythagoras theorem. Perfect. Let's move on to the next question. The next question that we do is question number 15. So show that these four vertices or coordinates are the vertices of a rhombus. What do we know about rhombus? This is simple one. What we know about rhombus is that in rhombus all four sides are equal. So let's try and, so let me draw a rough diagram. So let's say this is A, B, C and D. All I need to prove is AB. To prove that, what I have to prove is AB is equal to BC is equal to CD is equal to DA. Because if all four sides are equal, then it's a rhombus. The special thing about a rhombus where the diagonals are equal, that's a, yes, that's a square. But right now let's try and prove it to be a rhombus. So AB will be equal to x2 minus x1. So that's negative 3 minus of negative 5, that's plus 5 whole square, plus y2, which is 2 minus of negative 5, that's plus 5 whole square. So this gives me negative 3 plus 5, that's 2. So 2 square, that's 4, plus 7 square, plus 7 square is 49. So this is equal to root 53 units. So AB is equal to root 53 units. Let's try and find the length of the other three sides. Let's look at BC. So this is root 53 units. Let's look at BC. BC will be equal to 2 minus of negative 5, that's 2 plus 5 whole square, plus negative 3 minus of negative 5, that's plus 5 whole square. So this becomes 7 square, that's 49, and this is 2 square, that's 4. So BC is equal to root 53 units. So we've got two sides equal to root 53 units. Let's try and see what is the measure of the other two sides. So CD, let's compare CD. So it will be 4 minus 2 whole square plus 4 minus of negative 3, that's plus 3 whole square. The square root, 4 minus 2 whole square, that's 2 square is 4, that's 7 square, that's 49. So this answer is also square root of 53 units. So CD also we figured out is root 53. Now let's find the last side, which is AD. Now what would AD be? That will be 4 minus of negative 3, that's plus 3 whole square, plus 4 minus 2 whole square. This will be 7 square, that's 49, and this will be 2 square, which is 4. Therefore, AD is equal to root 53 units. Since all four sides are equal, therefore quadrilateral ABCD is a rhombus. Done. Let's look at the next question. The next question that we solve is question number 16. So let's look at that question. Question 16 says A is given equal to some point ABC. These are 4 points of a quadrilateral. Find A if A is negative and AB is equal to CD. So A is a negative number and AB is equal to CD. So let's apply the distance formula for both of these and see what would it be. So AB is given equal to CD. So what is the value of AB? So this is AB, there will be negative 3 minus of negative 6, that's plus 6. My mistake, I told you that I always prefer to take the variable as the first term. I realize the variable is in B. So let me start with B then. Negative 6 of minus of negative 3, that's plus 3 whole square, plus A minus of minus 2, that's plus 2 whole square. So that's the distance of AB, which is equal to CD. CD would be 0 minus of negative 3, that's 0 plus 3 whole square, plus negative 1 minus of negative 4, that's plus 4 whole square, square root. Squaring both sides, what I get is negative 6 plus 3, that's 3. 3 square is equal to 9. Plus A plus 2 whole square will be A square plus 4 plus 4a. This is my left hand side, and the right hand side is 3 square, which is equal to 9, and this is negative 1 plus 4, that's 3 square, again equal to 9. So this 9 and this 9 gets cancelled. What I have is a square plus 4a plus 4 minus 9, which means minus 5 is equal to 0. I need to find factors of negative 5, the sum of which is 4a. So this would be plus 5 into negative 1. So a square minus a plus 5a minus 5 is equal to 0. Grouping them together, a times a minus 1 plus 5 times a minus 1 is equal to 0, which means a minus 1 times a plus 5 is equal to 0, which means a is equal to 1 or a is equal to negative 5. So I have two values of a. The question said that a is negative, which means since a is negative, therefore a is equal to negative 5. So I have only one value of a is negative 5. Let's figure out what do they want me to calculate. The coordinate of the point will be, therefore b will be equal to negative 6, negative 5. So that's why it is important to read the question carefully. In this case, there are no, it doesn't have, this one is not a solution because 1 is not a negative number. Let's move on and let's solve the next question. The next question that we solve is question number 17. You can put a star on this question, important and a unique question. Let's look at this. Let's read the question. The vertices of a triangle are these 3 points. Find the coordinates of the circumcenter. What's a circumcenter of a triangle? We've done this earlier. Circumcenter of a triangle is not the center of the triangle, but the circumcenter of the triangle is the center of a circle which touches the 3 vertices of the triangle. So basically it is a point from which if you make a circle which touches all 3 vertices of this triangle. So which basically means this is a circle and there is a triangle inscribed inside it, which means if these 3 points are on the circumference, which means that all these 3 sides, which is, let's call this O, OA, OB and OC will be equal. So I'm repeating, a circumcenter is the center of a circle which is circumscribed, which means the circle which will have all 3 vertices falling on the circumference. So since OA is equal to OB is equal to OC is equal to radii of the circumcircle, so this is what is given. So OA is equal to OB is equal to OC. Now we will need to find the coordinates of O. So do we know anything about O? Do I know any x coordinate or y coordinate? No. So let O be x comma y. So there are 2 coordinates, but 2 variables, both the variables I don't know. So this is x comma y. So now let me try and equate OA with OB and then equate OB with OC. Maybe I'll get something. So let's try. So this time, since there are 2 variables and I know nothing about either of the variable, I'll have to form 2 equations and solve. So let's look at the first equation. So OA is equal to OB. Now since both of these will have a square root sign, let me change the square root immediately from the first step itself, which means OA square is equal to OB square. So if I do this, I won't have to bother about the square root sign. Let's look at this. So this is x minus 5, that's OA, x minus 5 whole square plus y minus 1 whole square. Let me confirm, x minus 5 plus y minus 1. Like I said, I always prefer to keep the variable as the first term, which is subtracting something. This is my OA square, and what is OB square? OB square will be x minus 11 whole square plus y minus 1 whole square. Is this fine? Let me reconfirm. Yes, OB will be x minus 11 and y minus 1. I notice that y minus 1 whole square is common on both the sides with the same sign, so it just cancels out, which means x minus 5 whole square is equal to x minus 11 whole square. Let's open this bracket and see what do I get. So I get x square plus 25 minus 10x is equal to x square plus 121 minus 22x. X square plus 121, perfect. X square and x square gets cancelled. I get negative 10x plus 22x is equal to 121 minus 25. This is equal to 12x and this is equal to 21 and 4, that's 96. Therefore, x will be equal to 8. So I've got one variable x is equal to 8. Now let me try and equate OB and OC. Let's see if I am able to get some answer. So OB is equal to OC. Since OB is equal to OC, therefore OB square is equal to OC square. So let's do this now. I have already figured out the value of x, so I can either replace x now or I can let x be. So let's check. So OB and OC, which means x minus 11 whole square plus y minus 1 whole square. Yes, x minus 11 whole square plus y minus 1 whole square is equal to OC would be x minus 11 whole square plus y minus 9 whole square. I could have also replaced the value of x here. I already know the value of x, but let's see if I can work without it. X minus 11 whole square is common on both the sides, gets cancelled. So this is y square plus 1 minus 2y. I just expanded this. This will be y square plus 81 minus 18y. Y square plus 81 minus 18y. Y square and y square gets cancelled. So this is negative 2y plus 18y is equal to 81 minus 1. This is 16y is equal to 80, which means y is equal to 5. I've got both the values of x and y. Let's read the question. What do they want me to find? Find the coordinates of the circumcenter. Therefore, coordinates of the circumcenter is 8, 5. Coordinate of the circumcenter are 8, 5. Interesting question. First, you needed to know what does a circumcenter mean, and then you needed to apply the distance formula 2 times. One with OA and OB and the other with OB and OC, and then you should get some answer. Perfect. Let's move on and let's solve the next question. The next question that we solve is question number 20. Yes, question number 20. The center of a circle is 2x minus 1, 3x plus 1. Find x if the circle passes through negative 3, negative 1. So there's a point, let's name it A, which is on the circumference, which is negative 3, negative 1. And the length of the diameter is 20 units. So diameter is given to 20 units. I have named the center as O. So what is OA? Yes, OA is equal to the radius, which means it will be equal to diameter upon 2, which means 10 units. Now this question becomes simple now that we've done the basic part, which means distance will be equal to 10. So now I know the distance formula. Distance is equal to x2 minus x1 whole square plus y2 minus y1 whole square, the square root of it. So let's apply the distance formula. Distance I know is 10. X2, let's take this as 3x plus 1. So 3x plus 1, oh that's y2, my mistake. Let's first do x2. And now not that it makes a difference, but let's take x2 first. That's 2x minus 1 minus of negative 3, that's plus 3 whole square. 2x minus 1 plus 3 whole square plus now y2, which is 3x plus 1 minus of negative 1, which means plus 1 whole square, and the square root of this. Let's square both sides. So this would become 100 and this would be 2x plus 2 whole square plus this will be 3x plus 2 whole square. Let's open this bracket. This will be 4x square plus 4 plus 2 into 2, 4 into 2, 8x plus 3x whole square, that's 9x square plus 4 plus 3 into 2, 6 plus into 2, 12x, that's equal to 100. Let's add them up. So 4x square plus 9x square that's 13x square, 8x and 12x, that's plus 20x, plus 4 and 4, that's 8, 8 minus 100, that's minus 92. So minus 92 is equal to 0. Any common elements? No. So now I need to find factors of 13 multiplied by negative 2, negative 92, the sum of which should be plus 20. So let's do the factors. 13 into 92, I do not need the negative sign. So 13 is a prime number, so this gives me only 92. 2 times 46, yes, this is 26, this is 46. I've already got the factors 46 and 26. So 46 will be positive and 26 will be negative. 13x square minus 26x plus 46x minus 92 is equal to 0. Grouping them together, 13x, x minus 2 plus 46 times x minus 2 is equal to 0, which means x minus 2 times 13x plus 46 is equal to 0, which means x is equal to 2, or 13x is equal to negative 46, which means x is equal to negative 46 upon 13. So I have get two values of x. Let's see if any condition is given. As per the question, no condition. So we need to find the value of x. So x is equal to 2 or negative 46 by 13. That's why it's important to read the question. In fact, this is not in simplest form. So let me write this in simplest form. X is equal to 2, or x is equal to, at 13 into 3, that's 39. So negative 3, that's 7 upon 13. 39 and 7. So that's my final answer. I need to write my fraction in the simplest form. Done. Let's look at the next question. The next question that we do is question number 22. Question 22 says, point P is the center of a circle with radius 13 units. So PA is equal to 13 and PB is also equal to 13. PT is a perpendicular to chord AB. PT is perpendicular to chord AB, and the coordinates of T are negative 2, negative 4. We need to calculate the length of AT. So as soon as I see a right angle and I see a triangle, I can think of Pythagoras theorem. So let me try applying Pythagoras theorem. First, let me try finding the length of PT. Once I get the length of PT, applying Pythagoras theorem, I should be able to calculate the length of AT. So let's find length of PT first. So PT will be equal to 2 minus negative 2, that's plus 2 whole square, plus negative 7 minus of negative 4, that's plus 4 whole square, the square root of this. So 4 square, that's 16, plus that's 3 square, that's 9. So PT will be equal to square root 25, which means 5 units. So this is 5 units. Now in a right triangle PAT, using Pythagoras theorem, I get PA square is equal to PT square plus AT square, which means PA square is 13 square is equal to PT square, which is 5 square, plus AT square. 169 minus 5 square, that's 25, is equal to 80 square. 144 is equal to 80 square. Therefore 80 is equal to 12 units. Now the answer for square root would be plus minus 12, but since length can't be negative, therefore 80 is equal to 12 units. So we've calculated the answer for 80. 80 is equal to 12 units. Now in the similarly in a right triangle PBT, again using Pythagoras theorem, I will get BT square will be equal to 13 square minus 5 square. Therefore BT will also be equal to 12 units. Therefore AB will be equal to 80 plus BT, which is equal to 12 plus 12, that's 24 units. Done. It again required you to apply Pythagoras theorem and apply distance formula first. Now let's look at the next question. The next question that we do is question number 26. Let's look at the question. 26 says find the point on y-axis. So the point is on y-axis, which means the point will be 0, 1. It's on the y-axis. Done. Whose distance from these points A and B are in the ratio something and something. Let's call this point P. So what has been given is PA is to PB is equal to 1:2, right? Which means PA upon PB is equal to 1/2. Now in a distance formula, I have square root, which means let's square it right now so that my square root sign gets removed. So PA square upon PB square is equal to 1/2 square, which is 1/4. Now let's apply distance formula, and then this question becomes extremely simple. So let the point be 0, y, since it's on the y-axis. So let's look at the length of PA. So PA would be equal to 0 minus 6 whole square plus y minus 7 whole square. We're doing PA square, sorry. So PA square upon PB square, which will be equal to PB square is 0 minus 4 whole square plus y minus -3, which is y plus 3 whole square. So 0 minus 6 whole square upon 0 minus 4 whole is equal to 1/4. Let's look at this. Let's open this bracket. So this will be 6 square, which is 36, plus y square plus 49 minus 14y, and upon 16 plus y square plus 9 plus 6y, this is equal to 1/4. So y square minus 14y plus 40 and 30, 70, 85 upon y square plus 6y plus 16 and 9, that's 25, is equal to 1/4. Let's cross multiply. When I cross multiply, I get 4y square minus 4 into 14, that's 56. So negative 56y plus 4 into 85, that's 320, and 20, that's 340. This is equal to y square plus 6y plus 25. Let's take everything on one side. So 4y square minus y square minus 56y minus 6y plus 340 minus 25 is equal to 0. Done. Let's see if I can simplify this further. 4y square minus y square gives me 3y square. Negative 56 minus 6, that's negative 62y. And 340 minus 25 is 315. Yes, 315. So now I need to find factors of 315 into 3, the sum of which should be negative 62. So let's multiply 3 into 315. I need to find factors. So 3 is the first one, 315. 3 again, that's 105. No, I still need to go further. This will be 3, this will be 3, 9, 15, 35. Let's see if this works. 27 and 35, 50, 62. Perfect. So now I get my factors. I hope you remember how to factorize big numbers using prime factorization. So 3y square minus 27y minus 35y plus 315 is equal to 0. Grouping them together, 3y, y minus 9 minus 35, y minus 9 is equal to 0. Y minus 9 times 3y minus 35 is equal to 0, which means y is equal to 9, or 3y is equal to 35, which means y is equal to 35 by 3, which is basically 11 2 by 3. So I get two values of y is equal to 9 or y is equal to 11 2 by 3. Let's see if this is correct, and let's see what do I need to find next. Question number 26. The question says find the point of the x-axis. Therefore the point is 0, 9 or 0, 11 2 by 3. Remember that you need to write this in the simplest form, 35 by 3 will get you 1 mark deducted. Let's look at the next question. The next question that we do is question number 27. Now question 27 says the distance of point P, which is xy, from the points A and B is in the ratio 2:3. Now we need to show something, so to prove that something. Again, a question like the previous one where the ratios are given. So let's look at PA is to PB is given as PA upon PB is given equal to 2/3. Squaring both sides, PA square upon PB square will be equal to 2/3 whole square, which means 4/9. So let's apply distance formula and see where we reach. So PA square will be x minus 1 whole square plus y minus 3, that's y plus not 4, y plus 3, y minus -3, yeah, that's y plus 3 whole square upon, this is PB, which is x minus -2, which means x plus 2 whole square plus y minus 2 whole square, and this is equal to 4/9. Let's open the bracket. X square plus 1 minus 2x plus y square plus 9 plus 3 into 2, 6y upon x square plus 4 plus 2 into 2, 4x plus y square plus 4 minus 4y. This is equal to 4/9. Let's group things together. X square plus y square, so I have taken x square, I have taken y square, minus 2x plus 6y, so minus 2x gone, minus 6 plus 6y gone, this is plus 1 plus 9, which means plus 10 upon, this is x square plus y square plus 4x minus 4y plus 4 plus 4, that's 8, and this is equal to 4/9. Let's cross multiply again. So I get 9x square plus 9y square minus 18x plus 6 into 9, that's 54y plus 9 into 10, that's 90. It is equal to 4x square plus 4y square plus 4 into 4, that's 16x minus 16y plus 32. Let's put everything on one side and let's see what I get. I get 9x square minus 4x square, this term and this term gone, plus 9y square minus 4y square, so this term and this term is also gone, minus 18x. If I take 16 on the other side, it becomes negative 16x, so these two terms gone, plus 54y plus 16y. When I take negative 16y on the other side, becomes positive, plus 90 minus 32 is equal to 0. Let's group like terms together, and I get 9x square minus 4x square, 5x square, 9y square minus 4y square, 5y square, 18 and 16, that's negative 34x, 54 and 16, that's 60 and 70, so plus 70y plus 58, yes, plus 58 is equal to 0, and this is exactly what I had to prove. So hence proved. Done. Let's look at the last question of this exercise. The last question of this exercise that we solve is question number 28. The points ABC are given as something. These are the vertices of a triangle ABC right angled at A. So let me make a rough diagram. This is right angled at A. So this is A, this is B, this is C. A is 3, 0. B is given as A, -2, and C is given as 4, -1. We need to prove nothing. We need to find the value of A. So right angled triangle, which means using Pythagoras theorem. So using Pythagoras theorem, what I get is BC square will be equal to BA square plus AC square. Done. BC square is equal to BA square plus AC square. Now let's apply Pythagoras distance formula, and this is already squared, so I do not have to worry about the square root sign. So let's look at BC. So BC will be a minus 4 whole square. Like I said, I always prefer to keep my variable as the first term. Plus minus 2 minus 1, that's minus 2 minus of negative 1, that's plus 1, minus 2 plus 1 whole square. This is equal to BA square. BA square again will be a minus 3 whole square plus negative 2 minus 0 whole square plus AC square, which will be 3 minus 4 whole square plus 0 minus negative 1, that's plus 1 whole square. Let's open the bracket and see what do we get. So this is a square plus 16 minus 8a plus negative 2 plus 1, that's negative 1 whole square, that's plus 1. This is equal to a square, open this, plus 9 minus 6a plus negative 2 minus 0, that's negative 2 whole square, that's 4, plus 3 minus 4, that's negative 1 whole square, that's 1, plus 0 plus 1 whole square. So a square and a square gets cancelled. What I am left with here is 17 minus 8a is equal to 9 plus 13 plus 1 plus 1, 15. 15 minus 6a. Let's take them on one side. So 17 minus 15 is equal to negative 6a plus 8a, which means 2 is equal to 2a, which means a is equal to 1. Done. Let's read the question. What do I need to calculate? Find the value of a. Already done. Therefore, point B is equal to 1 comma negative 2. A very interesting chapter, as long as you remember that the distance formula is equal to x2 minus x1 whole square plus y2 minus y1 whole square, y2 minus y1 whole square, and the square root of this. Homework question 14, 18, 21, 23, 24 and 25. In question 23, they say give the answer correct up to 3 significant figures. So I would request you to revise what we've learned in grade 7 about significant figure. Thank you so much. Take care. Be safe. Bye-bye.